Good morning and good afternoon, everyone. We still have people joining, so we will start in about a minute or two. Good afternoon and good morning again to all of those joining us. I still see people streaming in. I'm going to give it 2 more minutes and then we will start. All right. So people are still joining, which is wonderful. It's great to see those participant numbers go up. We're going to go ahead and get started so we can be on time. Thank you everyone for joining us today. Welcome to the 6th session and final session of the CLIR Climate Resiliency Action Series. I'm Alice Rubin. I'm CLIR's Program Officer for Strategic Initiatives. Today, a panel of 4 speakers is talking to us about big data and the preservation problem. We're thrilled to have everyone here, and the moderators of our session, Justin Wadlin and Lisa Spiro, will do those introductions. You're welcome to participate in the note-taking and can place your name on it if you would like, but you're not required to. These notes will be archived along with video recordings of each session. And just so everyone knows, because we do get quite a few emails after the event, the video recordings will be found either on the program website or on CLIR/DLF's YouTube page, and I will share links for all of that. Again, I will share the notes in the session, which should already be in the chat shortly after I finish. There will also be community-led climate circle, which is a more informal discussion. The 6th climate circle for today's session will take place on April 18th at 1 p.m. And again, I will share that link to register and more information about that towards the end of the session. Those talks are led by the DLF Climate Justice Working Group co-chairs, Justin and Lisa. And we will also potentially have some in-person networking at various conferences and share more about that once information is made public. Oops, someone's raising a hand right now. I just want to make sure I get to that if it's urgent. Sorry, everyone. Oh, People are sharing the docs. Thanks. 1 second. Okay. And now I want to thank our sponsors, the IMLS National Leadership Grant. Thank you to IMLS for everything you do and you have done, and we look forward to you coming back and being a robust funding source for all of us. They have provided generous support for this, and CLIR as well, as particularly from CLIR CIO Wayne Graham. We also had an advisory committee made up of the DLF Climate Justice Working Group members who have helped us put this together, namely Lisa and Justin, as well as Amy Dreer, and Lena Zentel, who were part of that, as well as our curriculum committee, who helped us come up with excellent topics, which you can watch on the YouTube channel and the website as we discussed. And that includes Jennifer Waxman, Jennifer Embry, Jody Gray, Trevor Bond, and Steve Diggs. Thank you so much to those people for allowing us to share this knowledge and move forward in this conversation. And now I'm going to turn it over to Justin.
Thank you. Would you be able to advance the slides to the speaker page?
Okay. Sorry. Next one.
Yeah, thank you. So our panelists today, I'm Justin Wadlin. I'm at Michigan State University Libraries, and our panelists today, Ben Goldman, Alex Kinnaman, Alan Munschauer, and Sybil Schaefer, will explore the intersections of energy usage, digital preservation, data storage, and archival and curatorial practices. I'm really excited to hear them speak. I'm just going to give a brief overview of what they'll be talking about and then their bios, and then I'll turn it over to them for their presentations. Excuse me. Ben Goldman will give a basic overview of the problem with big data relative to climate change, discuss the recommendations he made for making digital preservation practice more sustainable in his 2018 essay, Why It Isn't Easy Being Green, Digital Preservation in the Age of Climate Change, as well as his motivation for writing it. Then Alex Kinnaman and Alan Munschauer will share their study of energy usage around specific preservation practices and the tensions that exist between supporting environmental sustainability and meeting priorities to support energy-intensive formats and technologies. Sybil will then discuss economics and climate change, the link between climate change and institutional budget challenges, and how she's had to adjust her own digital preservation strategy to those budget issues. I am pleased to introduce you the first panelist, Ben Goldman, who is the university archivist in the special collections at the library at Penn State University. His research explores the intersection of archives, climate change, and the environment. After him will come Alex Kinnaman, who is the interim assistant director of digital libraries and preservation at Virginia Tech. She develops digital preservation policy and workflows through collaboration with several library departments, and her research interests include exploring strategies for preserving complex digital objects like digital humanities scholarship and 3D models, the preservation of community collections, and sustainable digital preservation. She holds an MLIS from the University of Illinois Urbana-Champaign and from MIT and an MIT from Virginia Tech. Presenting with Alex is Alan Munschauer, who currently serves as the Digital Collections Archivist at Virginia Tech University Special Collections and University Archives. He previously was the audiovisual curator at the University of Mississippi Archives and Special Collections. Alan has been the technical coordinator for the Meetings Coordinating Committee of the Mid-Atlantic Regional Archives Conference since 2021. A certified archivist, a DAS holder, and graduate of the MLIS program at the University of Maryland, his research interests include music communities, copyright, digital preservation, and climate-minded approaches to digital archives. And finally, Sybil Schaefer is the digital preservation analyst for research data curation and Chronopolis, program manager at the University of California, San Diego. She established and leads the National Digital Stewardship Alliance Climate Watch Working Group, which tracks climate science and related media reports to assess impacts on digital preservation activities. She has published and presented extensively on digital preservation practice and infrastructure, as well as digital archives workflow, disruption and management, and open source software. She serves as the Chronopolis Program Manager and Digital Preservation Librarian at the University of California, San Diego. She holds an MLIS and a specialization in archival studies from UCLA. And I will, at this point, hand it over to Ben Goldman. We will have time at the end of this session for Q&A. As the speakers speak, you can use the Q&A or the chat, but we won't really bring those up until all the panelists have given their presentation. Thank you.
Thank you, Justin, for that introduction. Let me pull up slides here. Oops. Okay. Yeah, thank you, Amanda, Justin, Alice, everyone involved in DLF and CLIR for putting this series together. I'm honored to be here. Thank you, everyone who's taken time out of their day to be here. I was just actually looking at the attendee list and saw a lot of old friends. So hello, old friends. So I'm going to be honest from the start. I do feel a little out of place on a panel titled Big Data and the Preservation Problem. I think I was invited to be a part of this because of this article that I wrote several years ago called It's Not Easy Being Green, Digital Preservation in the Age of Climate Change, which I think may have been one of the first published attempts to locate a response to climate change within digital preservation practice. So this was officially published in a book by the Society of American Archivists. You can see that here in 2019, but I started writing it in 2016 when I actually was a practicing digital archivist, and I had been, engaged day to day in the kinds of issues that I raised in that article. And I publicly shared an open access copy in June 2018, which was pretty much the moment that my professional trajectory shot off in another direction, away from digital preservation work entirely. So I do feel in the slightly disorienting position of having helped start a conversation that I didn't actually stick around to participate in. But I'm really pleased to see how much talk has continued and how much work has continued, including by my co-panelists here. So all that being said, my main goal for today is really to tee up Alan, Alex, and Sybil, hopefully by providing a very basic overview of the connection between digital preservation practices and climate change. I'm guessing many people here already have some familiarity with this issue, in which case, please consider this a refresher. But for those who aren't familiar with the premise, I hope my talk can be a useful introduction to the information they're going to share. Since I'm not up to date on current practices, I'm really going to frame my comments in terms of my thinking at the time, but I'm eager to hear or to learn if any of my assumptions might have changed since then. And I also want to acknowledge that our profession has a much greater set of challenges right now than we did 7 to 8 years ago. Okay. Is anyone seeing my slides advance or no? Okay. All right, well, this is embarrassing. There we go. Just gonna leave it there. So before we get to the topic of digital preservation, let me try to summarize the problem with big data in 4 charts for you. Data centers use a lot of electricity, roughly 2% of total US consumption at the time that my writing was published back in 2018. During the 2010s, there were a lot of reports predicting the growth of data storage and its energy appetite, but nothing, as I recall, like the growth that we're seeing projected now. As you can see in this chart, a lot of it obviously driven by what's happening with AI. So US electricity generation is still heavily reliant on fossil fuels. And for the years leading up to my publication, most of that electricity was generated through burning coal, which we all know is one of the worst sources of greenhouse gas emissions. Last year was the first time that renewable energy sources actually exceeded the use of coal in the US, which is great news. The bad news is that US emissions reductions stalled out last year as demand for electricity grew. And as you can see from this chart, we're making up a lot of that difference using natural gas. So data centers also consume an astonishing amount of water, and especially in places where water resources are scarce. In 2023, it was just determined that data centers directly consumed 66 billion liters with an indirect footprint estimated at just under 800 billion liters. And for a rapidly warming world, this is a lot of water. And of course, the reason these numbers are so important to us is because the planet needs to rapidly decarbonize in order to slow its overheating. And the US is currently not on track, unfortunately, to meet its emissions reductions commitments as agreed upon in the Paris Accords, which are pretty much universally viewed as the minimum amount of progress we need to make to really avert the impacts of climate change. Okay, so that's the really quick version of the problem, I guess. My interest in this topic originally peaked around 2009 when I was reading news articles referencing research that the energy consumption of 2 Google searches was roughly that of boiling a kettle of tea. I have no idea why that stood out in my mind, but those kind of analogies that kind of ground these issues always seem to catch my attention. And just looking at the literature on this, from there I discovered that this has been an issue that's attended us since the beginning, really, of the internet. There was an article published in 1999 called "The Internet Begins with Coal," which estimated that 8% of US electricity was being used to power the internet. Both of these findings were ultimately contested, probably wildly overstated at the time, but for me, they established the reality that both data storage and computing processes required energy consumption, which I was then connecting to my work in digital preservation. So around the same time, there were numerous reports documenting this projected exponential growth of digital data, and you were starting to see organizations like Greenpeace were paying attention and getting involved in these conversations. And libraries were too. I recall this conversation happening at various library conferences and meetings at the time. But my impression was largely that we were kind of framing this as an IT problem. And I thought the urgency of climate change probably warranted a deeper interrogation of accepted digital preservation practices. So to summarize, it was my belief that through a critical reexamination of our practices related to specifically redundancy, fixity, and selection, we could still meet our preservation commitments while also reducing energy consumption. So to be fair, I was never under the illusion that libraries and archives were a significant contributor overall to these carbon emissions, but I was always troubled when I was doing this work by the degree to which we deployed redundancy as a preservation strategy. So when I was more involved, Penn State was, kind of like summarily the activities we were involved in. We were hosting digital content through the university's data center. We had copies that were being geographically distributed within the state. We were in the process at the time of developing our own preservation repository and defining requirements for how many copies were needed, what kind of derivatives would be produced for different types of records. We were part of 3 different consortial preservation programs, and I don't know if we're still part of all 3. But each one had its own kind of system and philosophy of replication and redundancy. And we were also capturing websites using Archivit. Like many digital archivists, my day-to-day work was engaged in things like forensically imaging computer media, and in some cases, separately preserving files extracted from those images. And I guess in sum, it kind of felt like a lot. The ease of duplication is one of the great benefits of digital and one of the advantages I think we have with digital preservation, but it was clear that these activities had the potential for an extensive and possibly excessive amount of duplication. I really had no clue at all when I put the idea out there what kind of energy impact was associated with an activity like fixity checking. But this to me was an example of a process similar to the Google search electric kettle comparison, in that an inestimable number of minor computing processes could add up to a measurable impact. And while I understood the value of verifying file integrity, there seemed to be very little guidance on when and how often they should occur. And as an archivist, I wasn't ready to justify a high frequency of checks for the sake of an uncompromising level of fidelity. I know Alan and Alex have some actual experience with this as opposed to my speculations, so I'm going to let them pick up this thread later. And finally, contributing the chapter for a book honoring Mark Green, an archivist who wrote widely and prolifically about archival practices, also gave me a way to introduce a topic that I thought was missing from some conversations around this, but potentially really useful and necessary in light of the environmental concerns, which was this idea of impermanence. Mark's writing was really fixated on how to thoughtfully deploy resources for the maximum amount of impact. And for a lot of people in the profession, he sort of decriminalized this idea of reappraising and deaccessioning archival collections. And I guess as I was writing this, I was thinking, like, I want to decriminalize the possibility of loss in a digital preservation context. And to paraphrase some of Mark's writing on the topic, he would say things like archivist power lies in deciding not just what to save, but also what not to save, and accepting that impermanence of records is not only likely, it's desirable in a lot of cases. So looking back at it now, but I might say in terms of reducing the environmental impact of digital preservation, careful appraisal and selection, especially for me as an archivist, might be the most important factor. That what we choose to preserve matters as much as how we choose to preserve it. So now I want to pull back the lens a little bit, I'm sorry, from digital preservation, just to focus on library organizations more holistically, because this is kind of where my work has gone in recent years. A few years ago, I worked with a couple of students to create an inventory of greenhouse gas emissions generated by the Penn State University libraries during one calendar year. And included in this inventory were the emissions generated by library data stored at the university's data center, which was then pretty brand new and was built with energy efficiency in mind. So keep that in mind with what you're reading. The information we received was not as nuanced as I would have liked. We did not receive a precise data size, and that total did not ultimately include emissions from any cloud-based content. But we knew this included all of our library systems and websites. It included the preservation copies from our digitized collections and from digital archives. And altogether, we were told that this occupied 165 virtual machines that accounted for 14,000 kilowatt hours of electricity, or what would be the equivalent of 8 metric tons of carbon dioxide. Now, by comparison, our 3 annex storage facilities at Penn State, which house over 2 million volumes, something like 90,000 maps, around 30,000 linear feet of archival collections, accounted for nearly 900 metric tons of carbon dioxide equivalent. So building emissions in the form of electricity and utilities, just like with data centers, this accounted for us for 95% of our organization's emissions. And there's, a lot of things that can be improved with this accounting that we did. But this kind of was eye-opening for me. And by our estimations, both employee air travel and commuting generated more emissions than our library data was generating. And my first reaction to these numbers was to wonder if this was kind of like worrying about plastic straws when you're driving a gas guzzler. Within the context of our library's organization, overall footprint, Clearly, a more meaningful impact would come from making our buildings more efficient. And in fact, we later learned that just adjusting the climate controls in some of these warehouse facilities using strategies proven by the Image Permanence Institute could lead to really considerable reductions. But where I leave you then, I want to go back just to the ethical imperative that for me really motivated the writing in the first place. I primarily framed these recommendations in terms of climate mitigation, that altering our practices would be helpful in reducing emissions. And we live in a different time now with maybe a different understanding of climate change. And there's a lot of information coming from scientists that it might actually be too late to reverse climate change, but they're very adamant that every reduction in emissions will decrease the severity of the impacts that we all feel and that are felt across the globe. So even if the impacts of digital preservation are minimal compared to the emissions reductions that are required elsewhere, I feel like these changes are still really essential. They'll make us more resilient in the face of accelerating climate impacts and dwindling resources, including, I don't know, potentially dwindling resources for future data storage. And to me, I feel like this also makes digital cultural heritage professionals important advocates within institutions that are trying to reduce their footprint. And to leave you with one final, hopefully optimistic thought, seeing the quantity of emissions from library data relative to other sources of library emissions makes me think that digital curation and preservation perhaps has a much larger role to play in helping institutions reduce emissions. And so I'm hopeful that we can continue this conversation and keep making progress here. And that is all I have for you today. I will hand it over to Alan and Alex. Thank you.
All right, thank you, Ben. Good morning, good afternoon to everybody. Thanks for joining us. And we really want to thank the organizers of this series and, of course, our co-presenters as well. This is, you got a preview a few slides ago. This is Green Goes With Anything, a revised version of our 2022 paper at IPRES. And we're calling this one Balancing Sustainability, Archives, and Outcomes. I'm Alan Munchauer. I'm joined by my colleague from Virginia Tech as well, Alex Kinnaman. And I'd like to say, first off, Virginia Tech University acknowledges that we live and work on the homeland of the Tutelo Monacan people, and we recognize their continued relationship with their lands and waterways. We further acknowledge that the Morrell Land Grant College Act of 1862 enabled the Commonwealth of Virginia to both finance and found Virginia Tech through the forced removal of Native nations from their lands. And also a note that our opinions expressed in this presentation do not necessarily represent the views of our institution or the university libraries for which we work. So like I mentioned, this is an abbreviated version of our IPRES presentation, and this one has a stronger focus on actionable first step recommendations, less focus on methodology for this case. You can find the full paper and presentation on the IPRES 2022 proceedings. So maybe somebody can drop that into the shared notes if you get a chance. So as digital library practitioners, we're investigating ways to guide digital curation practices more broadly across Virginia Tech university libraries while prioritizing considerations for environmental sustainability. And in doing so, we explore university and professional standards and ethics using the 2019 article Towards Environmental Sustainable Digital Preservation as a guide to focus on immediate areas that we can address in our digital library workflows. We investigated our workflows for appraisal, digitization, fixity checking, and storage choices to identify areas of improvement that find a balance between best practices and environmental sustainability. And we seek to understand the environmental impact of Virginia Tech University Libraries' digital preservation choices on the community in which we live. As a land-grant institution, our work with the community archives and the collecting of history of our area of Southwest Virginia is part of our institutional mission. Though there is a sort of inherent dichotomy when actively seeking out building and maintaining collections in or adjacent to extractive industries, while also considering the climate impacts of our practice specifically. This dichotomy is likely to exist in some form at most archives or historical societies that are taking a holistic view at the history of the place that they are in. For us here in Southwest Virginia, a couple examples which are depicted here are the region's long history of coal and also the Mountain Valley Pipeline. Coal trains continue to be a daily sight in our area, and railroad history is prominent both in the Highlands where we are and our nearby city, Roanoke, which was founded as a railroad town in late 1800s. And the Mountain Valley Pipeline, if you're unfamiliar, it runs from West Virginia through the East Coast. It runs north to south through our county of Montgomery County here at Virginia Tech. It went online in 2024. There were many years of resistance, which resulted in stalled progress, which is actually depicted in this photo, that kind of left the work sites looking abandoned. But ultimately, the approval for the pipeline's completion was ushered in by an outgoing senator from West Virginia who added it to a debt ceiling bill in 2023. Moving from our regional history to our institutional history, a couple other impactful practices that are still ongoing are the Virginia Tech Quarry and the Virginia Tech Power Plant. Our university mines limestone at its own quarry on the fringes of our town of Blacksburg. And having become a key design feature of campus architecture over 120 years, this rock has become affectionately known as Hokie Stone. And the 40-acre quarry, which is surrounded by a residential area, provides 80% of the stone used in campus construction here in Blacksburg. Our power plant at Virginia Tech generates an annual steam output greater than 943 billion BTUs and provides steam, heat, and electricity to the campus and beyond. Having now transitioned only to natural gas to operate the multiple boilers on campus, the power plant supplies at an efficiency considerably better than our local utility, which is Appalachian Power, AEP. However, considering the size of the operation here, they're only able to meet 8% of our Blacksburg campus's power demand annually, and this annual percentage fluctuates based on the time of year. And while the school's policy and history constitute one record, there's also been a parallel environmental awareness movement, often led by students and faculty here. And the university's dialogue around climate issues was always multifaceted and includes issues of local industry, recreation, and the intersection of local, state, and federally managed lands. 9.3% of land in Virginia is federally owned, including a large district of Jefferson National Forest, which is bordering our town of Blacksburg. We believe that understanding a bit of your regional and institutional history is important as it relates to climate, especially being information professionals. And I've pulled a few examples from our archives here covering campus organization history that was happening at Virginia Tech in the early to mid 90s. For one, there was a large effort to stop the installation of a coal boiler in 1995. Ultimately, the boiler was installed 2 years later, but it was equipped with some containment measures, a scrubber and baghouse system to control particulate and acid gas emissions. And the community voice was heard considering these measures, and eventually they got an older boiler retrofitted with these containment systems. And our coal boilers were thankfully taken offline in February 2020. The Virginia Tech Climate Action Commitment, official statement from the university, it aims to set the university on a path to carbon neutrality by 2030. Virginia Tech University Libraries is unique among other local energy consumers given its management of multiple stores of data in our institutional repositories, our digital libraries, special collections, and data repository. It's with this history and context in mind that we explore the current environmental impact of our digital library choices and recommendations for decreasing this impact through changes in our workflows.
And speaking of those workflows, narrowing the scope even further to just Newman Library on campus, we're managing terabytes of data across multiple storage mediums. This includes some on-premise network attached storage and high-speed storage. We have DSpace, Figshare, Omeka, and quite a bit in AWS, both locally managed and in the third-party digital preservation storage, totaling around 120 to 130 terabytes that we know of. And that's all we really know right now. What we don't know are other library departments' usage, how much is redundant, what ephemeral or working items exist in their schedule for deletion, if there even is one, cloud storage, smaller hardware, and then how much storage and energy is expended by AI. Next slide, please. While the amount of data isn't fully known, there are a number of factors that we originally didn't consider for scope reasons, but that further complicate our goals to understand energy consumption. Thinking about strategic planning overall, most metrics are, number of digitized items, number of items accessible, number of efficiencies, but don't include environmental impact. And this is true for us here in the library as well as the university. We're in the middle of strategic planning in the library, and sustainability metrics are not included anywhere in our mission, our aspirational identity, or our strategic plan, or in the planning of the strategic plan. In order to keep our funding from the university, we're always pressured to do more and prove that we need the resources by doing more. And we're also increasing our AI exploration, particularly in the digital library and on complex files that are also in multiple viewers. So a lot of moving parts. At the university level, the library is not included in the climate action commitment plan that Alan mentioned, and we have no representation at all on the committee managing that project. So there's very little guidance provided to individual colleges and departments on improvements and impacts. Next slide, please. Electronic devices and appliances usually come with some kind of energy ratings, but when you're dealing with digital technologies, there's often a black box nature to their climate impact for a number of reasons that might include, lack of government regulations, industry secrets, or constantly evolving or streamlining. The data is not typically available. And AWS technically has energy reports, but when you don't know the data and the algorithms behind the numbers, it's difficult to trust their accuracy. Furthermore, to determine where your electricity is coming from, what type of encoding or compression is being applied to files, or what your geographic distribution looks like, there's just a lot of moving parts and work involved to sort that out. Next slide, please. Building on the issues the series has been exploring and our own context in Virginia, the big question we're trying to explore today is how do we balance environmental sustainability and archival work with the ongoing pressures to meet and exceed key performance indicators. Next slide. As far as actionable steps, in an ideal situation, broadly it would start with the top of the organization, providing tangible policies and plans, inclusive committees, and roadmaps that include good practices for conserving energy. At the department level, what we have a little bit more autonomy over are finding and implementing workflow efficiencies, like an SOP for how long we keep short-term backups, and relatedly reducing storage redundancy. As individuals in our respective fields, we do still have some control over how we prioritize the data, how we advocate for sustainable practices and educate our communities on those practices, and just being good role models to follow, to set an example. Next slide, please. The conclusion of our 2022 paper provided several broad recommendations to move V2L into a greener state in terms of our digital libraries and workflows. So using those recommendations as a jumping off point, and with additional contextualization and some new recommendations, we are hoping to spark a conversation about ways to address each of these opportunities. We'll start at the institutional level and proceed to action items that can be incorporated by a department or an individual. Next slide. Thank you. Starting at the organizational level, we highly recommend adjusting an existing collection policy or mission to reflect a commitment to sustainably manage digital resources and to guide to future decision-making. This might look like a formal sustainability statement, a value added to your list of values, or a part of the criteria to consider before accepting collections. Using the very plainly stated charge of Pendergrass et al. To reduce digital content overall, appraisal and digitization practices are areas which should be scrutinized. A well-defined collecting policy will help control the scope and prioritize the collecting efforts. It may also be beneficial to directly name environmental considerations in future revisions of those collecting scopes. We actually have a committee that approves and prioritizes digitization projects, the Advisory Council for Digital Collections. Yes, it is ACDC. And their selection rubric focuses on mission-specific projects and technical details. So this is a point in our library that could be a logical check on unsustainable digital projects that we've put in the pipeline. Additional clarity in how collections are prioritized internally for digitization is another area to address. Our existing ACDC committee could again be that logical check. This should also exist within submitting library departments prior to review by this council. And the departments should be able to clarify how collections are prioritized internally. Departmental collection digitization prioritization typically focuses on time and effort, access restrictions, copyright, uniqueness. And again, we see that sustainability goals are not a component of that prioritization. Next slide, please. And if the previous recommendation doesn't quite work, try reframing sustainability as cost effective. Yesterday, I had the pleasure of being on a panel at CNI with Snowden Becker, and she said, instead of thinking about how cheaply can we get this done, how can our necessary expenditure on preservation of digital assets become an investment? And I think that really applies well to this situation as well. Making any decisions to do less or preserve less is potentially in conflict with meeting those KPIs. So we show that the cost of recovering data is far more than management and maintenance, creating lasting value in the digital assets to, on paper, keep the numbers up without having too many copies, and reducing storage use reduces costs, etc. In the case of available AI metrics and the lack of specific sustainability data, speed measurements might be used as a proxy. Similarly, options like AWS Glacier give archives a slower, cheaper, and more sustainable option when speed is not the primary objective. Often the default can be to reach for the fastest and most readily available technology, but there is an underlying cost to that readiness. This is particularly prevalent in digital humanities work. A lot of projects come in where they want to use the new cool, shiny tool, and then maintaining that over time becomes completely unsustainable, so we're left with half-finished projects over time. I'll pass it back to Alan.
Thank you. So for sustainability commitment, we recommend that Virginia Tech University Libraries develops a sustainability statement for our digital libraries to scope our work and to also emphasize that not only the importance of, but the immediate need for greener digital library curation strategies. This one could be challenging. We acknowledge we all have red tape when it comes to affecting our entire organization's mission, and starting at the department level maybe could serve as a step towards advocacy in making those smaller changes a little quicker. Moving to the department level specifically and content that you may manage, we refer back to Pendergrass et al. Paper to emphasize the importance of determining our acceptable loss. Our IT division has similar protocols in their software, and the same should be applied to all our collections. Simply reducing security, such as hashes, and reducing the number of copies will reduce energy consumption. We need to determine acceptable loss for each of the storage vendors we contract with, and alter our workflows with mechanisms for faster healing to compensate for any loss. This might look like defining a percentage or fixed number, or generally reducing frequency for preservation activities, understanding that more manual investigation will be necessary. As with fixity, environmental impact of digital library choices is also very difficult to define. We found we might have anywhere from 2 to 8 copies of a digital object based on storage locations on site and off-site. Appraisal at all steps of the workflow is key. In the case of large ongoing digital collection migration, collection needs are considered individually rather than across the whole platform. And this extra time and effort dedicated to the process is in service of efficiency and minimizing future waste, such as when your institution may switch from one cloud storage service to another and you need to address years of unchecked management of both personal and shared storage. We have not determined what Pendergrass describes as the acceptable loss, or the level of acceptable loss in collections under our care, to make better use of what resources we do have, indicating improved and increased appraisal is necessary. We also found that energy efficiency is almost always measured by financial cost rather than by environmental cost. Libraries are businesses, and energy consumption is usually conveyed in terms of money, but measuring the environmental impact would not only help us decrease that impact, but could positively affect our bottom line as well. All of our initial results are really showing us that all we haven't considered really that impacts energy consumption, storage usage, and financial cost. As noted in the previous slide, we must investigate stricter preservation appraisal methods by expanding our current levels of preservation and modifying them to incorporate more direct appraisal. This is especially relevant in terms of all storage costs. Less content means less money, less energy consumption, and less manual labor. There are also actions we can take as individuals in this process. The libraries are responsible for keeping up with digital trends and practices and educating the university and larger community, and we're experts in this field. So we recommend regular training sessions on ensuring good practices in personal and professional archiving that also emphasize environmental sustainability. For us at Virginia Tech University Libraries, this is again especially relevant as more data comes our way from the university community. Streamlining the transfer process for accessioning materials or internally will help minimize the multi-department storage redundancy of working files. Understanding that redundancy is a necessity, we aim to determine which stages of the collection management process should be the most secure. Scheduling a process for deletion after migration and quality assurance is also key. This is especially relevant for VTUL, our Virginia Tech University Libraries, as redundancy across the university has revealed some cybersecurity risks, and for the library in defining the canonical collection. Among digitization practices, organizations should identify areas where changes can be made. In some cases, this will mean going against industry standards of resolution or bit depth. While the biggest results will come from a reevaluation of standards contributing to file size, simple cleanup to digitize materials can play a role in your sustainability goals. This could just mean addressing duplicate or blank pages, or editing dead air, or trimming commercial or non-relevant content from digitized sources prior to repository ingest.
Reducing ongoing fixity checks is a conversation that has been happening more frequently in the digital preservation field. And after our little investigation into our own fixity practices, we do recommend reducing scheduled fixity checks down from every 90 days to every 120 days, maybe 180 days as a start. To account for this, we should increase spot checking fixity from randomly selected subsets of files in each collection, and increasing test restorations to account for that decreased fixity checking. This could also include using different hashes based on size, even less frequency on items in cold storage, and reducing the number of points where fixity is run. Next slide, please. Just to give you a brief sense of the complication of trying to calculate energy consumption of a fixity check, we ran this on the data we held in 2022. And disclaimer one, these results are based on others' research, and validating this, even the small amount of investigation, would be very time intensive, and it would be in collaboration with our AT division and our vendors, which we still just don't have the support or bandwidth to perform. Disclaimer two, my original calculations were incorrect. I am a librarian for a reason, and an iPress audience member actually helped me correct them. So these results are the correct number. They are running 3 fixity checks on the data that we held in 2022. And the result was, 3 fixity checks, so in a life cycle, so maybe, before ingest, on ingest, and the next scheduled fixity check resulted in 0.5 kilograms of carbon dioxide equivalents. That's about a half a pound of coal, 0.05 gallons of gas. And those are from this very neat little EPA translation tool. And if this is accurate, if this is anywhere near accurate, this is concerning. And it has been a clear motivation for us to modify our workflows. Next slide, please. The size of the digital object directly impacts the energy consumed in running fixity, in transferring between storage locations, and ongoing storage maintenance. So we recommend exploring collections or data types where there are options for creating lower resolutions or otherwise just smaller objects. One area we are successfully exploring are lowering resolutions specifically for access copies and derivatives, which has helped with reducing storage and also speeds up transfer and rendering times. Next slide, please. So all of these recommendations, they're very broad. Some of them are very big, some of them are in conflict, but they have served us as a first step for rethinking as a librarian within our individual day-to-day work, how to be a little bit more sustainable over time. Next slide. So again, the original paper was presented in 2022, and we started making changes based on those original recommendations and on changes occurring within our university. We have officially changed the fixity frequency to every 120 days, but unfortunately, we also have to use a larger hash algorithm due to our AWS storage requirements and because they are more efficient for complex files. I am working with our 2D and 3D labs to generate smaller file sizes and resolutions for access files. And we're finally beginning to discuss better appraisal for what goes into AP Trust. So we're not forsaking our preservation practices, but trying to save space wherever possible, which again, it really helps us on multiple fronts. We also added additional considerations when accessioning large digital files in special collections and university archives. All potential donated materials within the collecting policy and scope are considered, but there's extra consideration given for larger files to be able to sustainably manage them. Lastly, in an overhaul in university-wide Google storage allotments, created quite a scramble and broad conversations around digital preservation and appraisal. And it was a literal digital box of chaos for about a year. And many departments and colleagues actually came to the library and leaned on our expertise and resources during that transition. Next slide. More recently, we've had more substantial changes. A significant one is with our 3D content. We use X3D, which is a very large 3D file format. It has multiple packages. It has a lot of embedded metadata. We use this for preservation, but we switched to using a much more lightweight GLTF file format for access. And this has drastically reduced the storage necessary for the 3D files. We're about to launch an alpha fixity service API, which I'm so excited about. This will enable us to see the actual health of the system and to monitor our trends in digital asset management. For the labs, we've again established regular and intentional deletion of working content so that we're not keeping a billion extra lab copies indefinitely after they've already been ingested to their final storage and access platform. The digital library is really becoming a centralized storage location as well, which will again help with monitoring and better preparing preservation plans. We're actually in the process of intentionally migrating a legacy 30-year-old Virginia Tech institutional repository-like digital collection site. So we'll be migrating this to 2 other systems, which will include the digital library, and that's drastically reducing file redundancy and improving metadata quality. And lastly, second to last, we've just received our meta-archive content back from LOCKSS after meta-archive sunset, which I think will be a very useful exercise in appraisal. And finally, I'm so excited about this too. We're beginning a library-wide storage survey to answer some of those original questions on, what do we even have that we mentioned earlier.
In the long term, we do want to explore the time and money that's expended in all these steps to really identify and reinforce areas for improvement. We also want to explore other preservation activities for energy consumption to determine what is justifiable to run more often and what should be performed sparingly. We would love to actually validate the energy consumption numbers from this investigation by collaborating with our IT division and the vendors that have our content. And lastly, we hope to use AI to our benefit, beginning with finding redundant files, producing smaller workflows that increase our efficiency, and in our metadata optimization, such as not having a million spreadsheets, but a centralized location where we can work with that data. And that's it for us. Thank you for listening to us, and we look forward to further discussion after our final presentation.
Hey everyone, can you hear me?
Yes.
Let me pop into presenter view. Okay, can you see my slides?
Yes.
Yes.
Awesome. Thank you. Okay. Hi, everyone. Thank you to CLIR, DLF, and IMLS for having me and supporting this series. I'm going to tackle this topic from a bit of a different viewpoint. The other speakers have primarily discussed how to mitigate carbon emissions in digital preservation work, which is critically important. However, mitigation is not enough. There's growing recognition that we've passed the 1.5 degrees Celsius warming target, and globally carbon emissions are still increasing. We need to address how we can adapt to the effects of climate change that are happening now and are projected to worsen in the future. When we think about climate change, we generally are talking about the effects of global warming, things like sea level rise, extreme weather events, ocean acidification, temperature increases, ice sheet and glacier melting, and changes in precipitation patterns. These effects present concerns about the physical location where we keep our data centers. Will they be affected by sea level rise? Or are they at increased risk of wildfire? These types of direct effects underscore the need for maintaining geographically dispersed copies of data as a preservation strategy. In addition to the direct effects of climate change, there are a whole host of indirect effects that we should be aware of and preparing for. But these are often not as commonly discussed because they are indirect. It's harder to draw the line from cause to effect. For example, a farmer migrates elsewhere for opportunities because there's drought in his homeland. To connect that migration to climate change, you'd first have to determine if the drought was caused by climate change. In many cases, it's not that climate change caused the drought would have occurred anyways, but it's the severity of the drought that was increased due to temperature increases from global warming. So we have indirect effects such as food security issues, water scarcity, human health impacts, human migration, social and political instability, ecosystem and loss of biodiversity, and economic disruption. And it's that last indirect effect, economic disruption, that I'm going to be focusing on in this presentation. You know, when you're a kid and you ask your parents a question and they give you an answer, and then you ask why, and they give another answer, and then you ask why again and again, until finally they answer something like, because that's just the way things are. Well, sometimes asking why continually actually yields an interesting answer. I learned that my library was receiving an 8% budget cut last year. And like most folks, my first question was, why? Well, because the UC San Diego campus received a 3% budget cut from the University of California system. Well, why did the system-wide budget get cut? Because the state of California, who allocates the University of California's system budget, was facing a deficit of at least $68 billion. So why was the state of California in such a budget deficit? The primary reason was less than expected tax revenue. But what I found really interesting is that both in a fact sheet released by the governor's office and in a press conference that Newsom gave, which this is a screenshot from, climate change was listed as a factor. Between December 26, 2022 and January 17th, 2023, 9 back-to-back atmospheric rivers, or as Newsom calls them, rain bombs, hit California. These caused 21 deaths and $3 billion in damage. But they also delayed the 2023 tax filing deadline for 99% of California residents. This means that the state government was unaware of the 22% drop in tax receipts and unable to incorporate that in its budget, adding to its overall deficit. And it was due to this deficit, indirectly increased through delays caused by atmospheric rivers, which ultimately resulted in cuts to the UC San Diego library budget. I just need a sip of water. Atmospheric rivers are flowing columns of condensed water vapor in the atmosphere responsible for producing significant levels of rain and snow. They're an important source of water for California. 50% of California's precipitation comes from these storms, including 40% of the Sierra Nevada mountain snowpack. However, in California, atmospheric rivers are also responsible for more than 80% of the state's major floods. Warmer air can hold more water, leading to more significant and damaging rainstorms. As one study found, atmospheric rivers have shifted during the 1980 to 2023 timeframe and have become more frequent, larger, and moister. Their increased frequency is especially concerning as atmospheric rivers arriving in rapid succession cause 3 to 4 more times more economic damage than they would have individually by drenching already saturated soils and increasing flood risks. Atmospheric rivers are projected to increase almost linearly with temperature warming. Under one emissions model scenario, a recent study predicted that there will be a global doubling or more of their occurrence and precipitation rate, and a tripling of those for those who fall on land. The atmospheric rivers that hit California in the 2022-23 winter and caused the delay in tax receipts were made more dangerous by global warming, and that they could carry more rain and were more likely to occur in succession, thus capable of causing more damage. The atmospheric river events that contributed to the California budget deficit last year caused about $3 billion worth of damage. Overall, extreme weather events caused by climate change cost the U.S. $182.7 billion in 2024. The number of weather and climate disaster events that cause $1 billion or more in damage has increased dramatically in the last few decades. Last year, there were $27 billion weather and climate disaster events, and since 2023, there have been an average of $23 billion events per year. This is compared with an average of $6.7 billion events in the 2000s, 5.7 in the 1990s, and 3.3 in the 1980s. It's not just natural disasters that are costing us. One recent study reported that even if we drastically reduce our emissions today, the world GDP is committed to an income loss of 19%, or about $38 trillion annually by 2050. This study only measures effects on agricultural productivity and labor and does not include the cost of natural disasters. An even more recent study took into account the interconnected nature of the world's economy and projected a possible 40% in loss in GDP by 2100. So let's bring it back to digital preservation. To handle our rather large budget cut, the first action taken by our administration was a hiring freeze. This means that when a critical system administrator retired last fall, we were not and are not able to replace them. This gap in technical support, which could easily grow as other staff retire or change positions, means we can't guarantee long-term support for our flagship digital preservation system, Chronopolis. This past January, we started an initiative to move from Chronopolis to Merit, the UC digital preservation system. As Merit relies predominantly on cloud service vendors, we will be moving from owning and operating our own digital preservation infrastructure to essentially renting storage with a preservation layer on top. Another side effect is that we'll be evaluating the materials under preservation stewardship with an eye to reducing them in size, looking more closely at not only what we're preserving now, but what we add to our digital collections moving forward, and also reevaluating the promises we make about how we steward our materials. To help us determine how to evaluate our collections, I've drafted a preservation stewardship matrix. This is not groundbreaking work. There are lots of examples to draw from, as well as a really helpful NDSA decision matrix. I've been actually wanting to adopt something like this for a few years, but now that we have a per terabyte yearly charge, it's become a lot easier to justify conducting the evaluative work needed to incorporate this across every unit in the library that brings in digital collections. And what's really been highlighted is the fact that we need to think critically about the large data sets we accept or generate. We can't digitize films without asking the question of if we can support what it costs, not just this year, but every subsequent year we steward our material. We can't afford to spend $75,000 a year preserving half a petabyte of data from a single lab on campus, which is actually a quandary we are facing now. So the basic evaluation rundown is, and please note that this is still a draft and has not gone through full approval process, but we have 3 levels. Gold is essentially the level that will get full digital preservation stewardship. Not only will these materials be preserved in Merit, but We'll conduct the necessary preservation actions to ensure continuing access to them. These are essentially high research value, unique materials that are part of our collecting strategy. The next level is silver, which is for things like materials that can be redigitized if needed, or collections that are over 5 terabytes in size. And these will be preserved in most likely glacier with some sort of fixity checking. We haven't really quite worked out those details yet. And then last is the basic level, which consists of materials like access versions that can be regenerated, licensed materials, etc. These are not considered under preservation care, but will receive basic backup. So, looking forward, UC San Diego is projecting a $500 million loss in funds from the federal government, which means more budget cuts and most likely layoffs are in our future. The budget cut we just received increased our vulnerability and decreased our resilience to adapt to these new budget cuts. And that's how it's going to be for the foreseeable future. Climate change is not just warm summers and less snow on the ground each winter. Aside from natural disasters, which are very much directly felt, climate change presents disturbances in the system, which affect us in different ways we don't always link together. You can complain about the price of olive oil going up and blame inflation, but you may not be aware that production is down because the Mediterranean has heated due to global warming, and olive trees are sensitive to the heat. The same thing is happening with chocolate and coffee, much to my chagrin. And at face value, actions like taking over Greenland and Canada seem like an unnecessary disruption of the post-World War II order, but they make sense in the context of global warming. Greenland has critical minerals under its melting permafrost. Canada has fresh water, and melting sea ice is expected to open Arctic shipping routes. My point is that the indirect effects of climate change are occurring even if they're not always obvious because the connections aren't being made. These changes will continue to grow in number and severity and reduce our resilience. There's only so many cuts a library can take before the cost of stewarding digital library materials becomes just one more service that we can't provide. I want to start to wrap up by contextualizing some of the factors at play when we look at a GDP reduction of 20% caused by climate change, as I mentioned in a previous slide. So the US debt today is about $37 trillion. A child born into the US today owes a debt of about $100,000. Each taxpayer owes over $300,000. Federal debt to GDP ratio is 122%. Our economy is dependent on growth. A 20% reduction in GDP is devastating. On top of that, we're not very good maintainers. There's approximately 168 trillion in deferred infrastructure costs. And I mention infrastructure because I view digital preservation as an infrastructure service. Infrastructure, if it's not working, ultimately means GDP loss. It's a bit eye-opening when you correlate the GDP of countries who have reliable electricity against the GDP of those who don't. So my question is, who's going to pay for all of this? Our economic future is not promising, and our institutions are under attack. The preservation of data is an ongoing commitment to resources. How do we preserve if we have no resources? It can be hard to get resources even in bountiful years, let alone the ones that we are facing. How much of today's politics around the world is shaped by the dawning recognition that the ship of modernity, sailing under the flags of development and progress, is going down? If the promises of modernity are broken, then we look for who to blame and how to take revenge. A lot depends, then, on the recognition that those promises could never have been kept, that they were not only unrealistic, but harmful. For only with this recognition is there a chance of working out what remains and what might be done, starting from the ruins in which we find ourselves. How much of what we are trying to preserve represents human attempts to know and manage and control the world? How much damage are we perpetuating by trying to bring it forward in time? I think what we'll find as we move into this new era that is rushing forward towards us at this very moment is that many of the petabytes we steward, The ones that were born out of the myth of progress and the notion that the world is for man alone to rule will be left behind. But what are the stories that will allow us to find paths where we can work with nature instead of against it? What stories will help humanity as the climate shifts from ideal Holocene conditions? We need to start thinking long and hard and ideally collaboratively about what we want to bring forward into the most unknown future that we have ever known. I'd like to end with a plug for the NDSA Climate Watch group. I started this group after I realized just how hard it is to keep up with climate news, especially when it gets crowded out by other headlines. We review climate studies, not just from science journals, but industry and government reports as well. And we write up brief annotations so that you can get the high points of the latest news. And that is all. Thank you very much.
Thank you, Sybil, and to all the panelists for your amazing presentations. We're going to shift now into the Q&A session, and we'll just, if all the panelists could sort of put your cameras on, and we've had some questions that have already come in the Q&A. I've just kind of noted them and acknowledged them. I haven't really answered them. And then I have some questions to get started myself. I actually am a little bit, I had my opening question, but now I'm not even really quite sure where to start. So I'm going to turn to the Q&A since I feel like it's, I want to make sure that we answer some of the questions from the audience. So, and this is a question that I wanted to ask. One of the participants in the session asked about the methodology around, this is for Alex and Alan, nope, sorry, Ben, about doing the inventory of the library's emissions. But I actually think the broader question that I had that relates to Alex and Alan's presentation is doing this inventory, like being able to get actionable data to make decisions on, because if you work at a university, you're working in a large organization where the area where you may be able to influence is limited, so you have to work through the different power structures. So I'm just interested in your the methods that you use to get the data, to just kind of get a sense of what's going on in terms of energy usage and storage. Those are the two that I thought were worth touching on.
Should I go ahead then? Okay. Well, kind of like what I heard from Sybil, Alan, and Alex, I often felt like I was kind of slamming my head against the wall when I tried to make some of these, try to get people within our organization to think about this stuff. So I would say what made it possible for me to do a project like that was that Penn State has a really passionate group of climate scientists and sustainability folks and professors across staff across all like units of the university. And there's just like been this movement that I could then participate in. And I think I heard a lot of like real excitement from people when they were like, a librarian wants to be a part of this too. So I didn't know how to do any of this stuff. There are two other colleges that did emissions inventories. A lot of it was made possible because the university diligently tracks all its utilities and throws it into a system that can measure the, actual, based on the sources of electricity and utilities, they can measure pretty conclusively what the emissions of the university are. And they've been using that data to make recommendations on how to improve things at the university. And some of those recommendations have been really aggressive. And I will just agree with what they said too. The only time the university is willing to hear them is when there's like a bottom line involved that they can key into. So I don't know if this translates to people not at Penn State. I would say that I think a lot of universities do have carbon emissions reductions goals, like on record. There's a website where you can see them all, and maybe there's resources and programs that you could tap into to do the same thing. I don't know.
I'd follow on with that. Our approach was pretty myopic. I think I might have gone a little too granular because really I was trying to figure out how much energy is a checksum. Well, there's how many different algorithms to run a checksum. I'm like, okay, how little what's the littlest one? It ended up being MD5. And it was, we found a couple papers where people had tried to measure that themselves. So it was just a little math and a lot of conversions and some hiccups because I don't do math or conversions apparently. And then estimating our data was just that. It was estimating what we know we are going to run fixity on at some point in the near future and does not cover so much. There's so much data in the library that we don't know about that is valuable and important, but Alan and I might not have access to it. Alan was sitting, we were in a meeting last week and he was running through trying to figure out how much was just on the special collections and university archives, like one folder, and it was massive. And that's true for many other departments. So we were guesstimating on what I know I have and what Alan knew he had at the time. And that number has increased significantly. I mean, our AWS is possibly tripled in the last 2 years as we build it out. So it's really challenging to get those numbers. And I because we're not really included in university level goals and plans, I think it would be really challenging to go beyond the library. I think it's going to be challenging to go beyond our division in the library to have participation there.
Okay, so the next question, I'm going to go to the Q&A too for the next question. And also just I'll note, if you have any questions, feel free to use the chat or the Q&A, then we'll try to get to them. And so another person pointed out in the Q&A about preservation of big data and working with vendors. And I think that's something that's come up in a number of the talks. I'm wondering, and in particular, cloud solutions. And so how can you, like, to what extent can we advocate for even understanding what's going on with the environmental impacts of that cloud storage? Because then if it's using a vendor, there may be it may be that sort of black box phenomenon. So I'm curious how you all have navigated some of those decisions about using a vendor and cloud storage solution, and to what extent you've been able to get any data or even advocate for changes at that level.
I don't know if we really have. So we use AWS. My opinions are my own. I was not thrilled. We are members of the Academic Preservation Trust, which is also built on AWS. The difference being that, technically different and diverse. And they have a lot of infrastructure built around AWS so that we're tracking and monitoring. And I have gotten the ear of some of our developers, and that's why they're building a Fixity Service API. It will also act as an audit log. I think that will give us a much better overall picture of what we actually have in AWS. And like I said, they have they have sustainability reports, but they're under finances. They're all about like, how much are you saving money, and don't really show a lot of granular data. It's very broad, and I don't think that it's too accurate yet, but I don't have anything to compare it to. It's really challenging, but the decision was financially based and usability based. I think it was the cheapest option where we could customize the most, and that was why we ended up going with that. But that's just one of our platforms. We moved to Figshare because our homegrown solutions were not scalable, and it was taking too many resources to scale them up. For the institutional repository, we maintain DSpace, and that's been a challenge. We've recently been attacked by AI bots. It's gone down twice in the last week because of that, and they're working on upgrades right now. But that's been a challenge. Special collections and university archives. There's an Omeka instance. We're migrating the legacy platform. So there's a lot of things to consider, and we don't have the information. I think it will take quite a bit of effort from many departments to get there. But the decisions are, again, just financial almost entirely. And Alan, feel free to jump in. I spoke for Skula again.
No, I'll just say, yeah, I don't have a lot of exposure to the technologies that we're licensing or the cost necessarily. In that dialogue with the vendors on the occasion maybe that they may have a session, here at the library. But I think I'm mostly engaged with the appraisal decisions, and especially after seeing Benjamin's slide about the library overall usage, has me thinking, okay, yeah. I mean, I guess it's all part of one whole, which is the selection and the appraisal, and ultimately what we're digitizing. I kind of always go back to this thinking about, like having, say, a DVD that can be checked out, in a circulating collection. What's the energy consumption of that item in the physical space, and how frequently is it being used? And what would be the relative energy consumption of having that readily available through a streaming service or having it available 24/7? And that sort of, there's so many factors contributing to, frequency of usage, cost to preserve both physical and the digital, and availability, access, all these sort of things informing those decisions. So, yeah, while I may not be necessarily in tune with the vendor direct costs, I'm definitely thinking and trying to balance those aspects really with all the decisions when it comes to digitization and born digital stuff.
Okay, I'm going to try to formulate a question on the fly. I just wanted to say, Sybil, I had your presentation was visionary, and I really appreciated it. I had a strong emotional reaction to it, so that's partly why I'm having difficulty forming a question. Because I think yours in particular gets at the disruptive nature of climate change and the way that it affects us personally in our jobs, and that we as professionals want to come with systems, models, and be reasonable, but there is this really intense aspect when it comes to affect you directly through budget cuts and rising costs, and all of us are experiencing that in one way or another. I think that it's a way to kind of turn this into a question that cuts across the different presentations is I think you talked about, what are the stories that we're going to bring forward into this future that we're living in now, and that the uncertainty of that. I think the decisions around appraisal, I think decriminalizing loss, I loved that phrase. I'm wondering if you all could speak to some examples of where you're seeing that happening now already, where you're being able to experience that in your professional lives. So that's my best attempt at trying to raise a question out of that comment.
I can start. I could say that one of the things that I've written into the preservation stewardship matrix that wasn't there before. We do a lot of research data curation and work a lot with our researchers on campus to take their data in and steward it. And if the data was already in a federal database or repository of some sort, we assumed that would be the preservation repository for that data. And that's a shift that we're making. Also, as part of the draft, things that are included are materials that are at risk because of political purposes. I think we're all aware of the current climate and the fact that there are a lot of information, a lot of things like our farm workers movements, LGBTQ plus rights materials, things that document indigenous people on indigenous lands. All of those types of materials are at a much higher risk now than they have been previously. And I think it's those types of materials that we really need to make sure are protected and moved forward into the future, because I think it's those stories of resistance are going to be things that we want to have remembered in the future. Yeah, and I'll leave it there.
I've been thinking about this a lot. This question that you asked, Justin. There was a little convening that Sybil was at last year too, where some of these topics came up. And in terms of being an archivist and thinking about archival appraisal, a lot of times what we talk about in our profession is, there's sort of this like elevator version of describing our profession as preserving the past for the benefit of the future. And like the things that Sybil brought up in her talk really collapse that definition for me a lot and make me think about like the importance of immediacy and, meeting people's immediate needs in terms of what we decide to acquire, what we decide to preserve. And I don't know exactly what that means, but like to me, that's like one of the adaptations, that I think I see our profession making, that she's suggesting we should do more of.
I think we've seen more success at Virginia Tech at supporting community collections. Our relationships with cultural heritage organizations in the area have not always been positive for many reasons, but they are progressively getting stronger. There's trust being built there, and we are seeing more support in the library and more support on campus for preserving that cultural heritage and the like smaller community areas, historical societies, nonprofits, small town government documents, things like that. And the appraisal is of their own accord. So they are choosing what they provide to us without consequence. We take what they're willing to give. And that's been a positive note, I think, for us. Doesn't address I wouldn't say we don't want to take it, right? We want to keep these things. So appraisal becomes really challenging with the community collections, and we haven't really addressed that systematically yet.
We've also recently instituted some policy around digital humanities projects that come through the library, clearly outlining responsibility of all the parties involved, both in the creation, the administration, migration, the maintaining the system, and what sort of preservation are they expecting from us, which has me thinking a lot also about how that wasn't happening for a lot of material that came through, especially as I work through this migration that we mentioned in our presentation, of a system that's under the stewardship of archives and special collections here, but it really acted as an institutional repository for images purely, starting in the 90s. It was homegrown here, and anyone could contribute to that. So there was really no documentation, and things came from all over the university. And so, being very deliberate about, we're open to working with these groups and especially having them do selection and curating their own content. But, how are we thinking about how this material is going to be stewarded in the future?
Well, thank you. I am just keeping an eye on time, and we just have 3 minutes left. I am sorry to say that we won't have time to get to all the questions that have come up in the Q&A. Thank you for submitting your questions. I guess if any of the panelists can kind of take a look and see some of there are a few that have gone unanswered. A lot of thank yous and a lot of comments in the chat about how great this is. And Lisa, would you like to say a few words about the climate circle that we'll be having next week?
Sure thing. Yeah. Hi, everyone. So if you, like me, feel like you need to unpack this very rich and important conversation, I invite you to join me and Justin and other members of the DLF Climate Justice Working Group at our final climate circle, which will be on April 18th at 1 p.m. Eastern. This is an informal opportunity for conversation and for kind of thinking through what we learned in today's session, how we might take what we learned and act on it. So we welcome anyone to come join the conversation. And thank you for a fantastic start to that conversation from all the panelists today.
Yeah, and thank you for attending, everyone. And I think that's everything. Take care.